Welcome back in our class. So we are doing this one. Can you see the screen?
Yes, sir.
Okay. Now after this, we have measuring distance, right?
Yes, sir.
Look, the learning outcomes. D. Can you read?
Describe how to measure a variety of lengths with appropriate accuracy using tapes, rules, micrometers, and calipers.
So you have the ruler with you.
Yes, sir.
Any scale do you have with you?
Yes, sir. Ruler.
Yeah. How long it is? 30 centimeter or 15 centimeter?
30.
30. Okay, good. So 1 centimeter in between 0 and 1 centimeter, you see there are 10 lines, right?
Yes, sir.
So 10 lines is giving you 1 centimeter. Each
Yes,
of
sir.
the gap in between two lines giving you 1 millimeter, right?
Yes, sir.
And from this idea, we can say 1 centimeter equals 10 millimeter.
Yes, sir.
Another thing we can get from here, that is, with this ruler, we can measure till 1 millimeter accurately, right?
Yes, sir.
Like 1 millimeter is 0.1 centimeter. So if you measure anything, like you have eraser, right? The
Yes,
length
sir.
of the eraser, if you measure, then you will get the value till nearest millimeter, right?
Yes, sir.
So this instrument is giving you maximum 30 centimeter and minimum 1 millimeter accurately, right?
Yes, sir.
If you take 1 meter rule, that is 100 centimeter long, that will help you to measure till 1 meter, right?
Yes, sir.
And if the length is more than 1 meter, then you cannot use the meter rule or ruler anymore. Then you have to use the measuring tape. What you have to use?
Measuring tape.
Measuring tape. So this measuring tape can measure all the lengths, like if they ask you to find the length of your living room or drawing room, you should use the measuring tape, right?
Yes, sir.
This way, if they want to measure the distance from one place to another place in a street, then we are using measuring tape
Yes, sir.
because it's more than 1 meter. This is about the longer length. We are using measuring tape. But if we have to or use the instrument to measure the length of more smaller than 0.1 centimeter, that is 1 millimeter. So that time we have to use other instruments. The instruments are vernier calipers and micrometer,
Yes, sir.
right? Now, uh, first we are dealing with vernier calipers. In your ruler, you got 1 millimeter, right? The gap.
Yes, sir.
So if you divide this 1 millimeter into 10 equal parts, are you thinking how much smaller it will be? Very small, right?
Yes, sir.
That small part is giving you 0.1 millimeter,
Yes, sir.
and in centimeter it is 0.01 centimeter.
Yes, sir.
That much accurately we can measure with vernier calipers. Okay, so can you read the diagram, the labeling of the diagram in vernier calipers?
Vernier calipers are used to measure lengths till 0.1 millimeter or 0.01 centimeter accurately.
Just the diagram, you read the labeling of the diagram. What is written in the diagram? What is written in the diagram? Read jaws for measuring inner dimensions. Hello?
Jaws for jaws for measuring inner dimensions,
Mm-hmm.
screw clamp,
Mm-hmm.
stem for measuring depths,
Mm-hmm.
vernier scale, main scale, jaws for measuring
Okay.
outer dimension.
So this one, jaws for measuring inner dimensions. You know measuring cylinder, right?
Yes, sir.
Measuring cylinder, it has internal diameter and external diameter. So
Yes, sir.
sometimes we have to measure both. When we will measure internal diameter, that time we are using this, right?
Yes, sir.
The upper jaws. And when we are measuring the external diameter, we are using lower jaws. Okay. Then we have here main scale reading. Can you see the main scale reading? Hello, Abir? Abir? Hello, Abir?
Hello.
Abir? Are you getting me, Abir?
Hello.
Hello, Abir?
Hello.
Yes. So this one is main scale reading, right?
Yes, sir.
You see it's written here 0, 1, 2, 3, 4 this way till 15. Then we have vernier scale reading. Vernier scale reading, here you have 1, 2, 3, 4, 5 this way 10 till 10. So main scale reading you can get it easily. Uh, in vernier scale,
Hello.
we have to check the vernier lines, which one is in line with the main scale reading line. Okay, look, the next page we will get a reading like that.
আর কিছু শোনা যাচ্ছে না।
Now you can listen to me. Hello,
জি স্যার,
Abir.
শোনা যাচ্ছে।
Okay, look,
স্যার এর আগে কিছু শুনতে পাইনি।
Okay, look. Here we have main scale reading, right?
Yes, sir.
And this one is vernier scale.
Yes, sir.
Okay. This one we are getting in larger form here. Can you see it now?
Yes, sir.
This is 2 centimeter, then 3 centimeter, 4 centimeter. How we take the reading from the vernier calipers? To understand it, we will use this diagram. Look, this one
Yes,
is
sir.
vernier scale, right?
Yes, sir.
And this one is main scale. So in main scale, we will check which one is, which line is going just before the zero of the vernier. So we are seeing here 2, then another line. So it's 2.1 centimeter, right?
Yes, sir.
So the main scale reading is, we are saying MSR, main scale reading is 2.1 centimeter. Now the vernier scale reading, this line, and the main scale reading, we see that these two lines are directly matching, right, with
Yes,
each
sir.
other or overlapping with each other. But the other lines, not like these two. They are little bit far, right? Abir,
Yes, sir.
that's why we will take this reading. So here we are getting 1, 2, 3, right?
Yes, sir.
So our binary scale reading will be 3, then multiplied by 0.01. From where
Yes,
we
sir.
got this 0.01?
Mm.
This is vernier constant, right?
Yes, sir.
How we got this vernier constant? From here, right? Because
Yes,
vernier
sir.
calipers can measure accurately till 0.01, right?
Yes, sir.
That 0.01 centimeter we are multiplying with 3.
Yes, sir.
So it comes 0.03 centimeter.
Yes, sir.
And total length is coming MSR plus VSR equals 2.1 plus 0.03 equals 2.13 centimeter. So are you clear now how we got this reading?
Yes, sir. Clear.
A binary scale reading, how can we get, how can we measure? This way. Then we have micrometer screw gauge. You have the ruler still with you, right?
Yes, sir.
And we are talking about 1 millimeter in the ruler. So if you divide this 1 millimeter with 100 parts, 100 equal parts, then it will be very, very small, right?
Yes, sir.
That small amount of length we can measure accurately with micrometer screw gauge. That's why we wrote here we can measure till 0.01 millimeter or 0.001 centimeter accurately. Clear?
Yes, sir. Clear.
So here we gave one reading like the vernier calipers. We are keeping the object here, right? In between these two. Okay, the anvil and spindle. In between these two, we are keeping the object. It can be one copper wire. Okay, very, very thin, right? That one we can measure the diameter accurately using the micrometer screw gauge. So how we get the reading? Here we look, we have main scale reading, right? Abir, hello Abir, Abir. Abir. Hello, Abir. Abir, are you listening to me? Hello, Abir. Yes, Abir.
জি স্যার ডিসকানেক্ট হয়ে গেছিল।
Yeah. Now again you are corrected, right?
জি স্যার।
Fine, no problem. Look, we keep the object in between anvil and spindle, right?
Yes sir.
Maybe it will be one copper wire. It's very thin, right?
Yes sir.
And we can measure the diameter of the copper wire using the micrometer screw gauge accurately. Here I gave one example. Look, this one is main scale reading, okay?
Yes sir.
So in this main scale reading, we are getting the reading in millimeter. And in main scale reading, we have upper lines and lower lines, okay?
Yes sir.
The upper lines, each of the lines giving you 1 millimeter, and the lower lines giving you 0.5, 0.5, okay?
Yes
Like
sir.
this reading is giving you till 5 millimeter, then you are getting another line down, right?
Yes sir.
So the lower line is giving you 0.5 and the upper line is giving you 5. Clear?
Yes sir. Clear.
So it's coming 5.5. The main scale reading is coming 5.5. Now this one is called circular scale reading, CSR. And you see this line is matching with the circular scale line at 28. Here is 25. Then I'm using the torch. It will be easier for you to understand. Here you see it is 25, right?
Yes sir.
So after 25, 26, 27, then 28 is matching with this line.
Yes sir.
So 28, as we are measuring millimeter, 28 multiplied by 0.01 millimeter, okay?
Yes sir.
That's giving you 0.28. So it's coming 5.78, okay?
Yes sir.
5.78, and you are getting the reading in millimeter. You are getting the reading in millimeter, okay?
Yes sir.
I'm showing you the uh, multiplication here. Here 28 is the circular scale reading multiplied by 0.01 millimeter, okay?
Yes sir.
That's giving you 0.28 millimeter. Now it's clear to you, right?
Yes sir.
And there is a good news for you that I'm giving you the recording also, right? The class is going on. You will get the recording so that anything you cannot remember, you can get it from the recordings. Okay? Clear,
Okay
Abir?
sir.
Now we are done with measuring lengths.
Yes sir. Clear.
Measuring lengths using all the instruments we are done. After this we have measuring time according to the, I also showed you the calculation, all the calculation breakdown here, the one I gave you description above. So when I will upload this note, you will get all the things again, no problem. Okay.
Okay, sir.
Also, I will upload this note in the Google Classroom. Now you see measuring time. Using, can you read this measuring time part?
For measuring time, we use different types of clocks and stopwatches.
Yeah, yeah, continue.
Clocks, it can be uh, read in hours, minutes, and seconds.
Hmm.
How
Then,
to use? The clock is set to commerce at a particular time or start time is noted. The time event is then allowed to occur, and at the end of the event, the end time is noted. The difference provides the required time interval.
then continue.
Stopwatches, it reads up to 0.01 second. How to use? As the time event occurs, the stopwatch is started at the same time. At the end of the event, the stopwatch is stopped and the end time is noted. The reading provides the required time interval. Some precise stopwatches are connected electronically to the time event and hence more accurate.
So using the stopwatch, we can measure up to 0.01 second. That means if you divide 1 second into 100 equal parts, then we are getting 0.01 second. Look, in this stopwatch, we got 37 second, then 22. That means 37.22 second.
Yes, sir.
Okay. And in clocks, we get till 1 second accurately. So the stopwatches we are using in physics lab, in scientific research, in athletics, in treatments, and many other places. Okay,
Yes, sir.
then continue.
Base quantities and their SI units. A base quantity or basic quantity is chosen and arbitrarily defined rather than being derived from a combination of other physical quantities.
Okay, here we have 7 base quantities. That means you got meter per second, right?
Yes, sir.
When we gave the example of a scalar quantity, we got speed,
Yes, sir.
right?
Yes, sir.
And speed unit is meter per second. So we are
Yes,
getting here meter and second. Meter is, you know the formula of speed, right?
yes,
Distance over time. So speed is coming from two basic quantities. One is length, another one is time.
yes, sir.
This way we have 7 basic quantities.
Yes, sir.
Can you read them?
Mass, length, time, current, temperature, amount of substance, and luminous intensity.
Yeah, so the SI unit, SI unit of these base quantities are also given, right? Can you read them?
Sir. Kilogram, meter, second, ampere, Kelvin, molar, candela.
So we are using the first 5 mostly, right?
Yes, sir.
And the temperature one, you have to remember more carefully because sometimes we are mixing up with degrees Celsius, right?
Yes, sir.
And SI units, what is called SI units? Can you read?
SI units are used as standardized units in all measurements in the world. SI unit is the short form for International System of Units.
So SI unit means it's the International System of Units, right?
Yes, sir.
Then can you read?
Derived quantity. A derived quantity is defined based on a combination of base quantities and has a derived unit that is exponent, product, or quotient of these base units.
Okay, look, already I gave you one example, that is meter per second is the unit of speed,
Yes, sir.
right? So speed is derived quantity and meter per second is the derived unit.
Yes, sir.
Similar to that, we are getting some other derived quantity like force, energy, power, frequency, charge, voltage, resistance, all are derived quantity, but you do not need to memorize them. Just I gave this for knowing, for increasing your knowledge. Even in exams, it will not come. The derived quantity one, it will not come in O level exams, it will come in A level. Okay, AS. In AS, you have this topic again, physical quantities, measurements units. There we will have more discussion on this derived quantity. Okay,
Yes, sir.
and some other things. So just have a look on this part, derived quantity. You need not to memorize all this. Then continue with prefixes.
Prefixes are useful for expressing units of physical quantities that are either very big or very small. If you write out such big or small numbers, it will be time consuming and prone to errors.
Hmm. So here you got some examples of prefixes, right?
Yes, sir.
This thing you have to memorize because sometimes you will get the unit of power in megawatt. Sometimes you will get the unit of time in millisecond. That time you have to remember them and you have to uh, write this value. Okay, and
Yes,
sometimes
sir.
you will get the length of or the length of the wavelength of the electromagnetic waves you will get in nanometer. Okay, micrometer. That time we need it. Clear to you?
Yes, sir.
There is another one after giga, 10 to the power 12. You just remember it. 10 to the power 12 is tera. Okay,
Yes, sir.
10 to the power 12 is tera and it is T, capital T. Okay, tera. T E double R A, tera, and it is capital T. Okay, that's all of this topic, Abir.
Yes, sir.
So this topic is over, topic one, and I will give you one worksheet on this topic. That's your homework. Okay,
Okay, sir.
you have the printer in your house.
No, sir.
You don't have the printer.
No, sir.
Okay, if you don't have the printer, you have physics copy, right, for our coaching.
Yes, sir. Yes, sir.
So what you will do, you will write worksheet 1, you will write the topic name worksheet 1, then you will give the answer. Okay,
Okay, sir.
MCQ part. I am showing you the worksheet, then you will understand. Okay, Just give me 1 minute. Okay, I'm showing you the worksheet. Okay, look, this one is the worksheet. Okay, Abir. Hello, Abir. Abir,
Yes, sir.
look, the first question. Can you read the first question?
Hello.
Yeah, can you read the first question? Yes, Abir.
Which word is the name of scalar quantity?
Yeah, which one is scalar quantity here?
Hello.
Yeah, from the list you will get it, right? The list I
Yes,
gave
sir.
you in the notes, you will get this scalar quantity. Which one is scalar quantity?
Mm,
Abir, mass is the scalar quantity, right? Hello,
Yes, sir.
Abir,
Yes.
mass
Yes.
is the mass is the scalar quantity. This way, you will try to solve. Okay, all these questions I gave you here, MCQ questions, um, 15, 16, 17, 18, 19 MCQ questions. Okay, and
Okay.
I will upload the notes. From notes, you will take the help, and also you have the recording. Okay, use the
Okay,
recording
sir.
to get the ideas also. If you cannot answer any of the questions, we will discuss in next class. No problem. So what you will
Okay,
do by this time, you will write the answers in your copy. Okay, where you have to
okay, sir.
draw diagram, you have to draw the diagram, do the working for structured questions in your copy, physics copy, and you will scan it in your mobile phone. You have camera scanner, right? App.
Yes, sir.
With that camera scanner, you will scan all of them, not photo, scanning. Okay, scan and make it PDF.
Sir.
Okay, make it
Okay.
PDF and send it to me by tomorrow night.
Okay, sir.
Send it to my email, this physics mania email. You have to send it by tomorrow night. Then I will check
Okay,
and
sir.
discuss it day after tomorrow in our class. Okay,
Okay, sir. Okay,
got
sir.
it?
Yes, sir.
So it's clear everything for you. You have any questions?
No, sir.
Okay, that's all for today. Thank you so much for joining. Allah Hafiz.
Allah Hafiz, sir.